and welcome back. We are going to talk about the structure of the atom, and this is going to kind of incorporate some of those main contributors to the atomic theory. I'm sorry about the cough. Two learning targets: identifying the internal parts of an atom and understanding the experiments and models that are related to the atom. If you need to pause the video to copy things down, please do so. I'm going to kind of go through it pretty fast. So first was J.J. Thomson. And so he postulated that electrons existed using cathode ray tubes. Performing an experiment, saw that light could be bended when a magnet was put near it. And so that bending of the magnet meant that there was a positive and a negative feature to an atom. It contains mostly these positive particles, but there are negative particles present as well, and we name those negative particles electrons. He actually used the term corpuscles, but we call them electrons. Here is the cathode ray tube. So this was kind of his experiment where we had a positive and negative end and a beam of light, stream of the negative particles, and they were able to move those negative particles, like I said, using a magnet, creating a different magnetic field. And so that's showing the presence that there's something negative in an atom. Then we go to William Thomson. So same last name, worked with J.J. Thomson. William Thomson was the first to kind of throw around the idea of the plum pudding model, and then J.J. Thomson kind of adopted it, and it's known more for J.J. Thomson than William Thomson. But it's the model that shows a uniform positive space, and then there's these negative pieces scattered within to counterbalance that positive charge. Excuse the typo. And so here is the plum pudding model. Again, I'm sorry for the coughing. Then we have Ernest Rutherford. So he was the next to kind of come in line, and he really explained a nuclear atom, meaning that there is a positive dense center to an atom, and he called that the nucleus. He used the gold foil experiment to kind of determine this. And so if we have this positive center, that means the electrons are kind of traveling around the nucleus at relatively large distances. There is no rhyme or reason to where they're at. They're just outside of this positive nucleus. Atom is made up of mostly empty space, and the proton has the same magnitude of charge as the electrons. And so one proton would be a +1, whereas an electron is a -1. Bohr came in, and Bohr said, okay, so after studying hydrogen, he came up with the planetary model where we still have that positive center, but now those electrons are a little bit more organized around that positive center. They're not just willy-nilly kind of hanging out. And so he developed these levels, energy levels for electrons. We call those orbital levels. And his model could be improved upon still, and so that's kind of where Chadwick comes into the picture. So working with Rutherford, Chadwick noticed that there was a missing piece to this atom. It wasn't weighing what it should have weighed if you were counting up protons and electrons. And so there has to be a neutral particle, and that neutral particle is the neutron. And a neutron is a little bit bigger than a proton, but not by much, but it has no charge. So it's not affecting the charge of an atom. It's just affecting the stability. It's what is cementing that proton, those protons in the center, and keeping the electrons from just pummeling into the nucleus. And so Bohr's model can be adjusted. And so here we have the positive and negative pieces with the neutral pieces inside that nucleus as well. And so this is the Bohr model. And so at the end of this discovery, we have electrons, protons, and neutrons. Electrons are found outside the nucleus. They have a negative charge. Protons and neutrons are found inside the nucleus. Protons have a positive charge that are equal in magnitude to the electrons, and neutrons have no charge, and it's about the same mass as a proton. So protons and neutrons are much more massive than electrons, to the point where electrons can kind of be ignored. Their mass really doesn't have any consequence to the mass of an atom. And so the nucleus is small compared to the overall size of the atom. It's compact, it's in the center, it's very dense, And it accounts for almost all of the mass. Like I said, the mass of the electrons is kind of ignored. It's inconsequential to the mass of the atom. And so here's just kind of a comparison chart. So the electron is assigned a mass of 1 so that we can compare it to the relative mass of the protons and neutrons, almost 2,000 times bigger than the mass of an electron. And then we can look at the relative charges as well. And so chemistry of an atom comes from the electrons, not from the protons and neutrons. So yes, we know that there's a center atom and it does have a little bit of play, but really the chemistry is about the electrons. So as we go into bonding in our next unit, we're going to be focusing on those electrons. And so that's the parts of the atoms that intermingle. Remember, electrons are on the outside, the nucleus is in the center. And so the number of electrons is really what determines the chemical behavior. And when we talk about the families in the next lessons, we're going to look at how their chemical properties are based on the number of electrons that are really on the outskirts of an atom. We are going to kind of cover this in class. Atomic number, atomic mass, and elemental symbol are just parts of identifying an atom. And on your periodic table, they're kind of laid out like so. And we use this information to really count subatomic particles, which we'll do this in class together. So thank you for listening. Oops. And until next time, you have a marvelous day.